Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 8 to the power of x is equal to 80. Now, the first thing I'm going to do is I'm going to rewrite 80 as 8 times 10. So we have 8 to the power of x is equal to 8 times 10. Now notice how we have two 8s on both sides. And what I want to do is I want to move this 8 to our left-hand side. And the only way to do that is to divide both sides by 8. So if I divide both sides by 8, I get 8 to the power of x divided by 8 is equal to, these two cancel out, so I'm simply left with 10. Now, this 8 here is the same thing as 8 to the power of 1, right? And now, if we have something in the form a to the power of m divided by a to the power of n, this is equal to a to the power of m minus n. So a to the power of x divided by a to the power of 1, we can think of a as 8 here, x as m, and 1 as n. So if we plug this in, we get 8 to the power of x minus 1. This is equal to 10. Now 8 here, this is the same thing as 2 to the power of 3, right? So I'm going to rewrite 8 to the power of x minus 1 as 2 to the power of 3 to the power of x minus 1 is equal to 10. Now, if I have something in the form a to the power of m to the power of n, n, this is the same thing as a to the power of m times n. So 2 to the power of 3 to the power of x minus 1, this is the same thing as 2 to the power of 3 times x minus 1 is equal to 10. Now we have to simplify this, so we're going to distribute the 3. So this would be 2 to the power of 3 times x is 3x minus 3 times 1 is 3. Now this is equal to 10. So now we have 2 to the power of 3x minus 3 is equal to 10, and now I'm going to take the log on both sides. So now I have log 2 to the power of 3x minus 3 is equal to log 10. Now, an important property of logarithms is that, let's say we have something in the form log a to the power of b, right? Well, we can actually move our exponent b here to the front of the logarithm. So this would be equal to b times log a. And this is an important property because let's say we have some 2 to the power of x is equal to 5, right? A simple exponential equation. Well, we can just take the log on both sides, so we can move this exponent x to down, because we can't solve this equation if x is an exponent. We want it to be a real term. So that is why this property is so important. So in this case, as you can see, x in this case is an exponent. It's not an actual term. And if we want to find the value of x, we want x to be an actual term. So I'm going to use this property here and move our exponent here, 3x minus 3, to the bottom. So now we will have 3x minus 3 times log 2 is equal to log 10. Now, because we want to find our value for x, we're going to have to isolate it. So we can do that by first dividing both sides by log 2 to move our log 2 to our right-hand side. So then these two cancel out, and I'll be left with 3x minus 3 is equal to log 10 over log 2. Now, the value of log 2, this is equal to 0.301. And log 10, this is the same thing as 1, because any logarithm always has a base of 10. So this is the same thing as log base 10 of 10. And this is essentially asking 10 to the power of x is equal to 10. So what is x? And x is equal to 1, right? So log 10 is equal to 1. So now we have 3x minus 3 is equal to 1 over, now log 2, that is equal to 0.301. So we have 1 over 0.301, sorry. So 3x minus 3 is equal to 1 over 0.301. Now, 1 over 0.301, this is equal to approximately 3.3223. So now we have 3x minus 3 is equal to 3.3223. So I can simply add 3 on both sides. So now I have 3x is equal to 3 plus 3.3223 is equal to 3.223. Now I can divide both sides by 3 because we want to isolate x. These two would cancel out, and I would be left with x is equal to 6.3223 divided by 3 is equal to approximately 2.1074. So x is equal to 2.1074. And now, remember our original equation was a to the power of x is equal to 80. So if I plug in 2.104 into my calculator, so let's a to the power of 2.104, let me plug that into my calculator. So 8 to the power of 2.104, and yep, it is indeed approximately equal to 80. Because it's not the exact value of 80, but it is approximately equal to 80 because they Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have 9 to the power of x is equal to 18. Now the first thing I'm going to do is I'm going to take the log on both sides. So now I have log 9 to the power of x is equal to log 18. Now, an important property of logarithms is that, let's say we have something in the form log a to the power of b. We can actually move this exponent b to the front of the logarithm. So this is going to actually equal b times log a. So I'm going to use this property on log 9 to the power of x. So we can think of 9 as a and x as b. So I'm going to move our x here to the front of the logarithm. So this is going to equal x times log a. So now I have x times log a is equal to, sorry, it's not a, it's 9. So I have x times log 9 is equal to log 18. Now we want to isolate x, obviously. So I'm going to go ahead and divide log 9 on both sides. So now I have x is equal to, because these two cancel out, log 18 over log 9. Now 18 is equal to 9 times 2. So I'm going to rewrite log 18 as log 9 times 2. And now we're dividing this by log 9. So now, if I have a logarithm in the form log a times b, this is actually equal to log a plus log b. Because remember, if you guys already didn't know, when you're adding logarithms, you're technically just multiplying the two numbers in front of the logarithms. So now log 9 times 2, this is going to equal log 9 plus log 2. So now I have log 9 plus log 2 divided by log 9. And now this is the same thing as log 9 over log 9 plus log 2 over log 9. All I simply did was I divided this into two parts, because remember, if you add these again, you'll simply get log 9 plus log 2 over log 9. So now, log 9 over log 9, these two would cancel out, so this is the same thing as 1. So I have 1 plus log 2 over log 9. Now, log 9, well, 9 is the same thing as 3 squared. So now if I replace 3 squared for 9, I get x is equal to 1 plus log 2 over log 3 squared. Now remember, property of logarithms, that states that if we have something in the form log a to the power of b, we can move our exponent b to the front of the logarithm, so this would equal b times log a. So log 3 squared, that is going to equal, we move the 2 to the front of the logarithm, so we will have 2 times log 3. So now I have x is equal to 1 plus log 2 over 2 log 3. Now log 2, this is equal to approximately 0.301. And log 3, this is equal to approximately 0.4771. So now if I go ahead and substitute in log 2 and log 3 into our original equation, I get x is equal to 1 plus, now log 2 is equal to 0.301, so I have 0.301 over 2 times log 3. Log 3 is equal to 0.4771, so I have 2 times 0.4771. So now I have x is equal to 1 plus 0.301 over 2 times 0.4771. Now let's simplify this. 2 times 0.4771. This is equal to 0.9542. So I have x is equal to 1 plus 0.301 over 0.9542. Now I'm going to go ahead and simplify 0.301 over 0.9542. So this is equal to 0.3154. So 1 plus 0.3514 is simply 1.3154. So x is equal to 1.3154. And now I'm going to give you guys a similar problem, but which is much easier, and it doesn't require any logarithms. So our original problem was 9 to the power of x is equal to 18. Now I'm going to give you guys 9 to the power of x is equal to 27. So I'm going to ask you guys to pause the video and try to solve this problem. Alright, so I'm assuming you guys pause the video and try to solve the problem. So we have 9 to the power of x equals 27, and 9, this is the same thing as 3 squared. So 9 to the power of x, this is going to equal 3 squared to the power of x, which is equal to 27. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x, this will equal 3 to the power of 2 times x. 2 times x is simply 2x. So 3 to the power of 2x is equal to 27. Now 27, this is the same thing as 3 to the power of 3. So I have 3 to the power of 2x is equal to 3 to the power of 3. And if I have something in the form a to the power of m is equal to a to the power of n, then this means that m is simply equal to n, because if both the bases are the same, that means both the exponents are the same as well. So I have 3 to the power of 2x equals 3 to the power of 3, and our exponents are 2x and 3, so I'll set them equal to each other. 2x is equal to 3. Now if I divide both sides by 2, these two cancel out, so I get x is equal to 3 over 2. So this is our answer. And I can even go ahead and plug this in for x and see if it's right. So check. We have 9 to the power of x is equal to 27. X is 3 over 2, so we have 9 to the power of 3 over 2 is equal to 27. Now I can rewrite this as 9 to the power of 3 square root of that, which is equal to 27. Now 9 to the power of 3, well, that's 9 times 9 times 9. 9 times 9 is 81, so 81 times 9, which is equal to 729. So now I have the square root of 729 is equal to 27, and the square root of 729 is 27. So if 27 is equal to 27, because this is right, our solution is right.